Hello, everybody. This is going to be a quick demo to try to explain some of the confusion that I've seen in office hours about the pattern matching part of homework 3 from UW. And so what I want you to imagine is that you're trying to implement pattern matching in a language that you're building, kind of like ML. And so this is a data type pattern that Professor Grossman has defined for us. And it sort of gives sort of an idea of the kind of patterns that you're going to want to support for this language. There's wildcards, variables of string. So that's going to be the name of the variable. Unit P, that's the sort of type with no information, kind of like void. And so that one has no information with it. The const pattern, I don't know if you know this, but you can make patterns. We'll do that in this demo of integer constants. You can also do them with string constants. This is going to be just of int. Tuple is going to be a pattern list, so it's going to have children pattern that any of your sort of you're going to, in your assignment, you're going to end up, recursively going down these. You'll also recursively go down this pattern on constructor. Constructor has string, and that'll be the name of the constructor. We'll go over an example of that in a second. And then the pattern, which is the child pattern for the constructor pattern. The ML program I've written for this, I'm just going to imagine a point. You can imagine X and a Y here. Circle is going to be a point for its center, and then an int again for its radius. I wrote is overlapping with origin, sort of overdone it by including the types here just for clarity. But the case expression for this optional circle that I'm passed in, if it's none, I'm going to call that pattern A. It seems reasonable to say that that's false. That's not overlapping with it. And if it is, if it's there, if there's some of this this circle, I'm going to extract all of its parts out into variables, x, y, and radius. I'm going to call that pattern B, and then just check to see if the square of x squared plus y squared is less than or equal to radius squared. We can argue over whether or not this is a good idea. If I run this program, you'll see that I've chosen if radius is 6, I'm saying it's overlapping. That 5 just hits right on it. I've decided to say that's overlapping. I suppose we could argue over that, but that's not really important for this. So let's get to sort of writing these patterns A and B in terms of homework 3. Okay, and so let's call val pattern A equals that is a constructor pattern to start off, and it's none. And the child pattern of it is sort of this. Well, this is one of those constructors that has no children associated with it. So let's just use the unit pattern there. And that's pattern A. Pattern B, which is a little more interesting, I'm going to say that that is also a constructor pattern, but this time it's sum. I'm going to overdo kind of the amount of indenting I do here. And so this is a pattern. It has a tuple of 2 children, right? 2 patterns. One in turn, and one of them is the another tuple with 2 variables in it, and another one is just a variable. So let's do this. This is a tuple pattern. And let's get that going, right? That's the first part of it. And child of that is another tuple pattern. This one is going to have variable x, right? And variable y. We're going to close up that tuple pattern and then add on variable radius. Okay. And I think that's all closed up. Let's see if this runs. Okay. And so we see we have a constructor pattern for none. That's matching up with this one with the unit, the sort of void of ML. And this one, the REPL has sort of elided a few things, but it's a tuple with a tuple inside of it and a radius variable. And inside of this tuple right here is going to be these 2 variables. Okay, so that's that one. Let's come down here to another one, which does sort of maybe the other cases that I didn't cover there. This one is kind of a ridiculous one. It's called is radius 2. It's going to be passed in the same sort of optional circle here. And I've got this kind of crazy thing, like if this circle happens to have radius 2, I'm going to call that pattern C. That's true. Otherwise, any wildcard return false. And so I've written this little thing right here that says, it's true when it's 42 and like anything else, and it will actually evaluate to false. Okay. So let's more interestingly, let's write out pattern C and pattern D and look at what they look like. Okay, so val pattern C equals, this is just, again, a constructor pattern. And the name of the constructor is sum here. And then I have a tuple pattern, right, which has a list of patterns in it. The first one is the wildcard. And the second one is this const 42. And closing everything out just so that we had completeness here, I'm going to just do the pattern D is just the wildcard. Okay, close it out, run this again. Let me see, those are our patterns. So again, the REPL sort of closed it out. But my hope is that this little Rosetta Stone that sort of shows patterns in ML and what they look like in Professor Grossman's assignment will help people in getting through UW's Lab 3.